So let us now try and understand what happens when an acid is dissolved in water. So how does the concentration of the hydronium ions change when an acid is dissolved, when a strong acid is dissolved in water? In order to understand this, first we need to have a good knowledge about the molecule of water. As you can see here, this is the water molecule having 2 hydrogen atoms and 1 oxygen atom. And you can see that the oxygen atom has 2 lone pair of electrons. That means 2 pairs of electrons which are not bonded to anything. The other 2 are bonded to hydrogens, right? So now what happens is, when an acid is dissolved in water, this is HA is an acid which can dissociate into A and H, A minus and H plus. So this proton is donated to the water molecule. The blue colored one changes to red. That means the blue colored water is changing to hydronium ion H3O plus. How? By sharing a lone pair of, donating the proton to the lone pair of electrons of water. A strong acid, what happens is, it can donate all of its, it can dissociate all of its hydrogen or nothing but hydrogen ions or the protons, and it can form H3O plus, whose concentration will be more than, or it will be equal to the original concentration of the acid. In contrast, when a weak acid is dissolved in water, the proton transfer takes place to for the formation of hydronium ions, but at the same time the reverse reaction is also possible, where again the proton is transferred back to the weak acids. That's the reason why the hydronium ion concentration here is very less when compared to the original concentration of acid. Here is what happens at the molecular level when an acid is dissolved in water. So here you can see these are the molecules of acids with the light blue colored proton, nothing but the hydrogen atom which is attached to the acid. When it is dissolved in water, this is nothing but water molecule with 2 hydrogen atoms. Can you see the green ones when they are coming? You can see the color change of water molecule to red, from blue to red, indicating the formation of hydronium ions. And you can see that all the green balls, nothing but acids, are left without the hydrogen atom. Initially they had this hydrogen ion or proton attached to it. Now after that what happened? They donated their proton to the water molecules, resulting in the formation of hydronium ions, such that now this is called as the dissociation constant, children. Now for strong acids, the dissociation constant is greater, very much more than 1. Why? Because the hydronium ion concentration is more in the solution. Now what happens when a weak acid is dissolved in water? Unlike the strong acid, here the reaction attains equilibrium. This is what happens. So you can see the blue molecules of water here. When they come in contact with the acid molecules, you can see that some of the acid molecules donate their protons to the water molecule, resulting in the formation of hydronium ions. But as you can see here, that the concentration of hydronium ions is less here when compared to the strong acids, and that is the reason why the dissociation constant here is less than 1.